EIGRP over the top or OTP with route reflector. In this video, I'm going to talk about the EIGRP OTP again, but in this scenario, I'm going to show you how you can configure EIGRP route reflector. The topic same as or similar as the, for example, BGP route reflector. Let me to explain this scenario, the EIGRP over the top with route reflector. Look at to this scenario. In this scenario, we have 4 sites of a customer or a company. For example, the site 1 CE1, the site 2 CE2, and also site 3 CE3, and also we have another site, for example, the site 4. This is the site 4, but as you know, we should connect these sites together with for example, a service provider. Okay, this is the service provider, and in this scenario we need to establish EIGRP neighborship between the edge routers of the site 1, site 2, site 3, and also site 4. You know that one possible solution is that, for example, I configure a neighborship between R1 and R2 with EIGRP OTP, and then with R1 and R3, R1 and R4, and after that we should configure, for example, a neighborship in EIGRP OTP between router 2, router 1, router 3 and 4, and after that between the router 3 and all of the other routers, and router 4 and all of the other routers. This is the full mesh EIGRP OTP as you saw in the previous video. For full mesh configuration, we need many neighborship, we need many configuration, and you know that the number of neighborship is n multiply n minus 1, okay, and over 2. This is the number of the neighborship. For example, if we have 4 router in EIGRP, 4C router, and equal is 4, the number of neighborship is 4 multiply 3 over 2, and this means that we need 6 neighborship. But assume that, for example, we have 10 router, okay, 10 site. If you have 10 site and you need to configure neighborship between all of these routers, you need full mesh, the number of neighborship is 10 multiply 9 over 2, and this is equal to 45. Assume that n equal to 100. Many neighborship or many configuration you need. Because of that, in a large scale environment, large scale companies, we need another solution, and that is the EIGRP route reflector. EIGRP route reflector is the same topic, is a similar topic to the BGP route reflector. You know that, for example, in BGP route reflector, we can configure between the neighborship between BGP neighborship between the clients and the route reflector, and when a route reflector receives the BGP update from a, for example, client, it should advertise that update, it should reflect that update to other routers. Here in EIGRP route reflector, we experience a same topic. As you know, for example, here we have R1, R2 and R3 as clients. I configure R1 and R2 and R3 as EIGRP client, and also R4 as EIGRP OTP, for example, route reflector, EIGRP route reflector. This is a new topic in EIGRP route reflector. This is for the scalability of the EIGRP OTP. Now, assume that we have connectivity or neighborship between R1 and only R4. Again, R2 and only R4, and finally R3 and only R4. As you can see here, we have only 3 neighborship between the routers, and assume that, for example, with 4 router in full mesh we have 6 neighborship. Or maybe if you have 10 router, you need only for example 10 neighborship between the routers. If you have 10 routers, 9 of them are for example clients, and 1 of them is route reflector. Because of that we need only 9 neighborship. But You know that if you configure full mesh, you need 45 neighborship, and this is a good function for scalability. How route reflector or EIGRP route reflector should propagate the updates. Let me to show you. For example, R1 advertise the net A. Okay, this is the EIGRP update to R4. R4 should receive this update and send or reflect these routes to the R2 and R3. For example, in this scenario, because R4 has neighborship with router 2 and router 3, when R1 sends EIGRP update to R4, R4 should advertise this update to, for example, router 1, router 2, and also router 3. So easy. But for configuration of this feature, maybe we encounter some problems. Let me to show you how you can configure this scenario, and after that we can solve the problems maybe we experience. Okay, very good. Here, first we should configure the scenario. Don't forget, in the EIGRP OTP with the EIGRP route reflector, we have two types of routers. The first type is client, okay, and the second type is the EIGRP route reflector. Okay, the configuration of the client is same as the configuration of the EIGRP direct or point-to-point neighborship you learned in the previous video, but the configuration of the route reflector has some differences that I will show you when I configure this scenario. Let me first configure the addressing. After that we can talk about the configuration of the, for example, EIGRP BGP, EIGRP route reflector. Okay, here starting from the configuration of the R1, as you know, we have R1, R2, R3, R4, and R5. This is the configuration of the R1 in the previous scenario. I should change some configuration. After that, I can apply this configuration. As I said before, the configuration of the client is same as the configuration of the point-to-point neighborship. Because of that, only I should replicate the configuration, but the configuration of the route reflector is new. Let me to show you how you can configure R1, R2, and R3. You know that these routers are client routers in the EIGRP OTP. Look at here. First, the host name of R1 in R1, the interface ETH00's IP address is 10.1.5.1 because this is between router 1 and router 5. And after that, interface loopback 0 has this IP address quad 1, quad 255. Don't forget, we should have connectivity between the routers. For example, you know that we should send updates from R1 to R4, okay? And after that, R4 should send this update to R2 and R3. It's okay. But don't forget, after that, after, for example, learning the quad 2 with the R1, R1 needs to have reachability to the, for example, R2. Because of that, you should configure the static routes to have reachability to R2's IP address, not the loopback IP address, the ETH00. Because of that, I need this IP static route, IP route for the 10.250 quad 255.255.255.0 with the next stop of 10.155. The underlay connectivity should be established with any feature, any tools that you want, but the simplest form of the connectivity is the static route, okay? The IP route for 10.250, this link with 255.255.255.0 with the next stop of 10.155. Again, the IP route for the 10.350, okay? 10.350, 255.255.255.0, 10.155. This is the second static routes. And also, we need another static route for the 10.4.5, okay, IP route. If you want, you can configure, for example, an IGP between these routers to have connectivity or other tools, but the static route is simplest form. the IP route for 10.450.255.255.255.0 with the next stop of 10.155.